Okay, guys, we're back. Chuck says we have to answer your questions, and so we're going to start.
I didn't say we have to answer.
Yeah. You really put the arm twist on me, so we're going to answer your questions, guys. But first, I want to thank you for the time and trouble you've taken to ask the questions. It shows that you're thinking. That's good. But even better, it's made me think, and I've had to think about some of these things in order to make up the answers to them. So I'm going to start with the drawing where we left off. BC Block Ought To asked, did I inspect the bed? Yes, to the extent that it was possible. I used a straight edge on the top, and the camelback straight edge, so the bottom of it was pretty flat. I did not find any significant errors there. I made a little sled that went from here, actually from here, around to here, carrying a dial indicator, and moved the sled along and says, do I see any deviations? No. And the other thing is I used the dial indicator here, indicating way out here, so if there's any difference between this part of the bed and where the indicator is touching, the indicator would at least show some deviation. So to the extent that I was able to, with these primitive methods, inspect the bed, yes I did. The other test, if we look up here in the top view, and we notice that I had side-to-side play. So I used the dial indicator setup, the indicators mounted here on a mag base, reading against this base, and rocked back and forth. So I put this slide base in different locations along the bed of the lathe, and the amount of play did not change. So from that I concluded that the sides of the beds were at least reasonably parallel to each other. Another detail is that the bed are hardened and ground steel strips, and I would expect there'd be some wear on them, but I did not find enough that I would go to the trouble and expense of sending this off for regrinding. Okay, the second question. Adam Gallowitz, and by the way, I hope I pronounce your names right, and again, if I don't mention your names on this, it's more because you made just nice comments and didn't ask serious questions. So I'm going to answer the serious questions. So Adam Gallowitz and Roy Reynolds asked, could I shim the turret up? And the idea is that the turret sits here, and the holes in the turret are now low because I've been scraping the bed, and so could I shim the turret up this way to compensate? The answer is good idea, but no. And the reason is that there is a pin that goes inside here, and when the turret indexes, that pin retracts, allows the turret to rotate. At the end of rotation, the pin goes boom, back up. If the height of the turret above this face is changed, then the pin may not seat in the hole in the turret. There's a tapered pin and a tapered hole, and so any change in the axial position of the turret will affect the seating of the pin. The other problem is, of course, that adjusting shimming for height does not correct for any error in this plane going this way. So by the time I realized that the holes in the turret were oversized, I already knew that I would have alignment errors, so reboring the turret to compensate for everything all at once became the only way to proceed. Tom Bordelon asks if I should have scraped the dovetail slide rather than the base. So he would like me to scrape this because this is the place where most of the wear would occur. And if I were to restore this to exactly factory conditions, then yes, that's the way to go. But the problem is, I don't have a section of an end view of the slide. There are 8 surfaces involved in scraping dovetails, 7 if you don't count the gib, and they are small, they are tight, they're hard to get into, they're hard to see. Dovetail slides, small dovetail slides in particular, are hard to scrape. So because there is no significant loose or tight spots moving this slide on the base, it's easier to scrape here where all of the work is in the open and there's only 1, 2, 3, 4 easy to scrape surfaces. So that's the reason I don't scrape this, but have chosen to scrape this. It will not be factory original alignment. or the way the factory would do it, but this is the way that the most economical, the most feasible way to do it in the rebuilding. Muskeg Smith asks, can the high spots be removed by stoning rather than by scraping? And the answer is yes. Oh, Chuck, would you get my markers? I want to make a drawing. You can remove the high spots by stoning, but that creates another problem, and I want to illustrate that. So here's our average surface, and it's got little waves in it, but it's got a little bump. And so we take our stone, and we move it back and forth, and we abrade this. And it's going to get lower and lower and lower, and eventually this will be smooth. But the stone is very much smaller than the surface. And so the stone can only average the area that it is. It can only average over this part. And so, for example, if this were a deviation like this, it would have to average here to here over the length of its stroke. So the spotting tool, the tool that corrects the error, in this case, has to be as long as the entire surface that you're working. And you can't simply buy a stone that is straight, flat, say over, this is, I think, around 15 inches. The second reason is that a stone will remove only a very small amount of material compared to a scraper. Take just a tiny little bit off of this, you can scarcely see it. But every single cut that I make with a scraper, you can see an amount of material removed. So the stone is far too small. Again, it averages the surface. They are not available in the range of sizes and shapes that would be required to finish a variety of machine surfaces. And so no, stones are not used for correcting alignment and surface errors. Okay, let me turn pages over. So I've made notes, so I answered all your questions. I want to say a little bit more on Muskeg Smith. Reading my notes here. You know, I gave you the two short answers on the on this particular problem. I want to say just a little bit more about the methods used to generate accurate surfaces from inaccurate. If we were to go back into the 1750s, probably the best method, let's say prior to the invention of the planer, the best method for creating flat surfaces would have been a hammer and a chisel. And it is quite surprising what you can do with a hammer and chisel if you're a skilled hand. It's a lot of work. It's very very difficult. The process over the last, let's call it 250, 300 years of developing methods that generate accuracy from inaccuracy, that is geometric accuracy, lead screw accuracy, which gives, let me go back. Geometric accuracy gives us shape. Lead screws and other similar devices give us lengths. And one other problem we have is division of the circle, which gives us angles. Now, these principles are behind all of the machine tools of today, and behind a significant part of manufacturing, technology, engineering, and the sciences. So this is a very interesting topic. It's very complex. I only know that it is important, and I don't really know a lot of the details of it. The book Machine Tool Reconditioning by Connolly is perhaps the most easily available and accessible description of the generation of surface and geometric accuracy. It does not cover linear and division of the circle. For that, the book is Moore, by Moore Precision Machines, or Special Machines, I think it is, Foundations of like Mechanical Accuracy. A very, very good book, a bit expensive, but if you're really interested in the process of generating accuracy, those two books pretty much cover the subject. Continuing on, Dan Whiteford asks about scraping after grinding, and Bob Corves gave the best answer. Grinding leaves a surface that is very difficult to scrape. I know of one reason, and that is that the surface is very smooth. It is difficult for a scraper to get a bite into it. I have suspected that the process of surface grinding leaves a very thin hardened layer, and the scraper just simply is not hard enough. You cannot get enough pressure to cut through that layer. So no, do not grind and then scrape. The best choice for preparation of a surface to be scraped is either shaping or planing. The second best is milling. And apparently scraper hands can tell you the difference between the feel and how much work it is to scrape a milled surface versus scraping a plain surface. And the reason for that, I cannot tell you. Back to Bob Korvs. He wrote a great review of machine tool alignment by scraping and grinding. And Ralph Gottfried Hansen reminds me to learn to see the difference between contact spots. That's an important ability, and I thank him for the suggestion. Let's see, let me review my notes. There's page 1, page 2, page 3. Okay, here we are at page 4. That's about the end. Last but not least, Barry Gerbracht, I believe, asks some excellent questions. Why scrape? I think Bob Korvs answered your question pretty well, and better than I could. And I will add to Bob that scraping is a key part of the generation of accuracy from inaccuracy, and therefore the basis for today's accurately ground machine tools. And the second, turns out I didn't finish writing out. So he points out that I use the bed of the lathe as my reference surface, and that is not a precision surface in the sense that it is not calibrated and certified. It's not a surface plate. It is potentially and probably and very likely inaccurate, and that limits the quality and the accuracy of the work that I can do. The problem is, if we look at the end of this base, there is almost no surfaces that are available to a surface plate. Something like that. This surface and this surface are flat, but they are not used in guiding any of the pieces. So these can rest on a surface plate, but there is no way using a surface plate to spot this, 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 and this. Now, the Rivette factory would have a special gauge that was made to scrape this in. This surface would never have been scraped to a bed in the factory. It would have been scraped to another cast iron fixture that has exactly the shape of the base. These would have been scraped with special dovetail spotting tools and checked with various methods, including possibly autocollimators for straightness, certainly various straight edges. Those methods are not available to me, and so I have to use what's available. And that means that I accept the bed as sufficiently accurate for the work that I'm doing, and I'm using that as the reference surface. Okay guys, I think that's the answers I have for you today. We're going to reset the camera. I want to show you a question I have for you. Now, Barry's basic idea was that I have so much material to take off, why didn't I machine it? And the answer to that is in two parts. One is that when I did the lever cross slide, which is admittedly quite a bit narrower, it went faster than I had assumed that it would. And so without thinking through very clearly, I thought that I could scrape all of this surface into alignment within a reasonable span of time. Well, as I said, I was wrong. A small correction on these surfaces entails a larger correction on these surfaces. And so in the process of taking that side-to-side play out by scraping this down so that the bevels on this piece and the bed contact, I had to take a lot of this off. And now to correct the misalignments, I got to take a lot off of this and even more off of this. So here's the challenge. I'm going to put this on the mill. I think I figured out how to align this piece to the dovetails, which are now my reference, my datum surfaces, but I have to gauge how much to take off of this and how much to take off of this. In other words, if I take this down 5 thousandths, how much do I take off of this? So I need to be able to measure the bed. I need to be able to measure this to the bed and make this fairly close. So put your brains together, guys, and find me an answer. I think I have a couple of possibilities. Not quite sure. Chuck and I are going to spend a skull session here, see if we can figure out how to do this. The other thing that I have to do before I do anything else is these bevels are not 60 degrees, they're not 45 degrees. I can't buy a standard cutter. They're 55 degrees. So my first project in order to get started on this will be to grind a 55 degree tapered end mill that has a cutting length of just about, it's going to take me just about 5/8 of an inch. That's a 1/2 inch, so I want just a little bit more. So there's my challenge. We'll see how I cope with that one. Okay, guys, that takes care of my portion of number 58. I hope, looking ahead, I'm not quite sure when it'll happen, but I will show you the setup of this in the mill, and then I'll bring this back onto the lathe, and later I'll show you the process of boring and sleeving the turret holes. We'll see you then. Thanks a lot.